Hello there, college algebra students. This is Mr. Kashi speaking. With this video, we're going to go through our first day of 10.3, which means that we're switching gears over to geometric sequences. So the difference between a geometric sequence and an arithmetic sequence is that we are doing this with factors, or we have what we call a common ratio, which is represented by R, which means that we're just multiplying to get to that next number. So instead of adding each time, we're going to be multiplying. So for this first one, if we wanted to find the next four terms, hopefully you can see here we're multiplying by 3 and multiplying by 3 again, and so we'd keep doing that. So 18 times 3, that would be 54, and then 54 times 3, that would be 162, and obviously, hopefully you're going to see why you're going to need a calculator for this lesson, 1,458. You'll see how geometric sequences, they grow and decay much faster than arithmetic sequences do. So there's a formula that we use, and I just want to go through what each of these variables mean. So this a of n, this is what we were going to call our last term, or the term that we're trying to find. A of 1, that is our first term. This r right here, that is going to be our common ratio. And this n right here, that's going to be our term number. So if we were finding the fourth term, we'd plug in a 4 there. If we wanted to find the 50th term, we'd plug in a 50 there. So we're going to be using this, and I went to copy this, sorry, this should be geometric sequence formula. Alright, so geometric sequences, this is the correct formula that's there. Find the next four terms. So we have 4, 8, 16, and then find the 25th term. So here, you can see that we're multiplying by 2 each time, right? So the next one, hopefully you can say, 32, 64, might need a calculator after that to get to 128, and then 256. But now we have to get to that 25th term. So we're going to use our formula up there. We need A1, we need R, and we need N. So A1 we know is 4. That's our first term. Our R is 2. We're multiplying by 2 each time. And we want to get to the 25th term. So we're going to use 25. So here A of 25 equals 4 times 2 to the 25 minus 1. So just to kind of simplify that a little bit, we'd have 4 times 2 to the 24th. And that is something that you're going to plug into your calculator. And hopefully you can see after you do that how fast this grows, because this is going to get to 67,108,864. So yeah, obviously geometric sequences, they grow very quickly, up to the millions in this case by the 25th term. So this next example here, you can see we're going down. So I'm going to multiply by 1/3. We're always multiplying to do this. So here it's going to be 1/3. That's going to be our common ratio. So here you take 4 and you multiply by 1/3. Just leave it as 4/3. And then if you're to keep going, this would be 4 9ths, 4 27ths, 4 81st. And then to get to the 25th term, we would need to know, okay, we got A1, R, and N. Well, A1 is 36, R is 1/3, and our N is still 25. So to find A of 25, we got to plug those in. We have 36 times 1/3 to the 25th minus 1. So A of 25 equals 36 times 1/3 to the 24th. When you multiply that out, it actually gives you a scientific number, 1.274 times 10 to the negative 10th. That's a very small number that's going to have 9 zeros behind that decimal before you get there. So these two examples were just to kind of help you realize how fast or how fast it grows or how fast it decays when we're talking about geometric sequences. So we do have two more examples. I switched this one to the 15 because I wanted to be a little bit more manageable. So first, what we're going to do is we're going to have a common factor of negative 2 to get to 10. You're going to multiply by negative 5, and then we're going to multiply by negative 5 again to get to negative 50. So to find the next 4, you can just keep multiplying by negative 5, and so then this would be a positive 250, and then next would be negative 1,250, and then we have a positive 6,250, and then negative 31,250. And the point that I was going to make here is when you have a negative common ratio, you're going to alternate. Here, this is a negative, and then a positive, and then a negative, and then a positive, and then a negative. It's going to alternate back and forth between negatives and positives for your answers. So to find that 15th term, we need A1, R, and N. So A1 was negative 2, our ratio was negative 5, and our N, we're trying to find the 15th term. So A of 15 equals negative 2 times negative 5 to the 15 minus 1. So simplify that a little bit. And negative 2 times negative 5 to the 14th. And if you plug that in, remember it's going to alternate back and forth between positives and negatives, but our number is increasing. Even though it goes to a negative, I guess you could say it would be decreasing. So this goes all the way to negative, let's see, we got 12, 2, 0, 7, 0, 3, 1, 2, 5, 0. So that's a really small number because it's negative, but that would be negative 12,207,031,250. So we do have one more on this slide here. Here, this might be a little difficult to find out what our common ratio is. So what the easiest thing to do is to take your calculator and take the second term and then divide it by the first. So if you're to go 0.75 divided by 0.5, you would get 1.5, and that is our common ratio here. We're multiplying by 1.5 to get to the next term. So if we were to keep doing that, for the next 4 terms, it would be 1.6875, and then we'd get 2.53125, and 3.7969, and then 5.6953. And there's some more there that I had to kind of round off a little bit. But so then if we wanted to find the 15th term, we need A1, our ratio, and our N. So A1 would be 0.5, our ratio is 1.5, and then our term is going to be 15. We got to find A of 15. So we have 0.5 times 1.5 to the 15 minus 1. So here we have 0.5 times 1.5 to the 14th. And plugging that into your calculator, once again this is rounded off, but 145.964 would be your final answer. So hopefully you can see that was alternating, and here we don't need to just be doing whole numbers. We can be doing decimals, and we can have like a common ratio that isn't a whole number either. We can have fractions or decimals 1.5, like things like that. So our last problem we're going to do is we're going to find a specific term. They're just going to give us the first term and the ratio. So here they're just giving us what they need to find. So to find A of 7, we would need to use A of 1, which is 24, times our ratio of 0.5 to the 7 minus 1, just like that. So once you, I always like to simplify it a little bit, so I'm not plugging in subtraction into the exponent there. So 24 times 0.5 to the 6, we would get an answer of 0.375. That would be our 7th term of that geometric sequence. The next one gives us, we're going to find the 8th term. So a of 8 equals our first term of 4,096 times 1/4 to the 8 minus 1. So a of 8, 4,096 times 1/4 to the 7th power. And what happens after that, once you multiply all that through, is you actually get 1/4 or 0.25 as your answer. That would be the 8th term of that geometric sequence. So hopefully these examples helped out and get you ready for the ALEKS assignments on geometric sequences.